Yes, next is physical and chemical changes. Physical and chemical changes. Physical and chemical changes. Take a wooden pencil and break it into two pieces. Take a pencil, wooden pencil, just break into two. It becomes smaller, isn't it? This is a chalk. Now the size is big. If I break it, what happens? Yes, the size became small. Two small pieces. Size became so small. Isn't it? Yes. So its shape also changes. But it still remains a pencil. When I break the chalk into two pieces, what happened? The size changed. It became small. And shape also changed. At the same time, it remains as it is. Pencil is pencil, chalk is chalk. Yes. The nature of the molecules of the pencil does not change, or the nature of the molecules of chalk, it doesn't change when we break, because pencil remains the pencil, chalk remains the chalk. No new substance is formed here. We cannot see any new substance formed here, isn't it? No new substance is formed here. So a change in which nature of molecules of the substance does not change and no new substance is formed is the physical change. Here no new substances formed. No new substances formed. That is actually physical change. A change in which nature of molecules of the substance, it does not change. It remains the same. When we break the chalk or pencil, we got pencil only again. That nature it is same, but shape change as well as the size also changed. But no new substance is formed. Pencil is pencil, chalk is chalk. So this changes where no new substance is formed. That is actually a physical change. Yes, so it is called physical change. No new substance is formed here. Object remains but maybe in a different state. Like example, you can see here the image of a pencil breaking down into two pieces. Pencil remains pencil but its shape and size changed. Isn't it? Yes. You can see the image of a butter. Butter after melting, it is butter only. But one is solid butter, one is liquid butter. Isn't it? Yes. Then you can see ice and water. One is solid ice, the other one is liquid. Ice melt, it changes into water. But it's water itself. In both the case, the nature of water is water itself. Isn't it? No new substance is formed here. The object remains the same. So the change in which nature of molecules of the substance, it does not change. Or no new substance is formed. It is actually called a physical change. Now another example. With the help of an adult, light a matchstick. Light a matchstick. It will change into smoke and ash. When you light a matchstick, we can see some fire coming. After that, what happens? Smoke we can see coming out from the tip of the matchstick. And ash, black color ash, smoke. We cannot get back wood from smoke and ash. Yes. So after lighting the matchstick, the fire and ash or smoke comes out. From smoke and ash, we cannot get back the wood again. Wood we used to use as a fuel to burn it for the cooking food and all. After the wood burns, you can see ashes or black smoke coming out from that. Wood won't be there. Then afterwards, we cannot get back the wood from the ash or smoke. That ash or smoke, from that we cannot get back the wood. It won't get converted to wood again. Once wood is burned, we burned. It converted into small ashes and smoke. That smoke again we cannot convert it into, it never go back to wood again. So new substances are formed here, isn't it? When we burn the wood or when we light a matchstick, what happens? Ash and smoke we can see. New substance is formed here. So the molecules of smoke and ash are different from those of matchstick. These molecules of ash and smoke is different from matchstick. Both the substances are different. So molecules also different. A change in which nature of the molecules of substance changes. So the nature itself changed, new substances are formed. That is called a chemical change. So new substances formed. New substances formed, or we say nature of the molecules changed. Nature of molecules. Nature of molecules changed. So this is actually a chemical change. A chemical change is a change where nature of molecules changes as well as new substances are formed. Rusting of iron is an example of chemical change. Iron rust, iron. When it rusts, it becomes so black, isn't it? Yes. Then again it won't convert to iron. New substances are formed there. Everything changed there. Yes. So it is a chemical change. You can see the example. Wood. Now it's wood. See the image of the wood. Yes. When it burned, what happens? You can see fire coming out. After burning, you can see smoke and ash. We cannot convert that to wood again. So here what happens when we burn wood? New substance formed. The nature of the molecules is different. Before it was wood, now it is ash and smoke. Yes. Then we make cake from some flour. Yes. See, we use some substances to make cake, some powder, wheat powder, maida, etc. We mix the flour and we make the cake. From cake again we cannot convert to flour, isn't it? Yes. So making a cake is an example of chemical change. Here new substances are formed. Now nature of molecule is different. Before it was a flour. We mixed everything together. Then we make the cake. Yes. Then egg. Yes. Egg. See, egg when we boil it. Yes. See the difference. Before it was how and now how it is. So these are all examples of a chemical change. Yes. In chemical change, nature of molecules changes and nature of the molecules of substance change and new substances are formed. It is actually a chemical change. So physical change means no new substance is formed. The nature of molecules are same. Example, breaking down of a pencil and melting of butter, melting of ice, they are all example of physical change. The nature of molecules remains same, no new substance is formed. But in chemical change, the change in which new substances are formed or nature of molecules changes. Burning of wood is an example, rusting of iron is an example, baking a cake is an example. These are all examples of a chemical change. Okay? Dissolution of solids in liquids. Yes. Take some water in a glass. Add a spoonful of sugar into it and stir it well. The sugar disappears in water. If we take a glass of water and add a spoonful of sugar into it, what happens? Yes, we cannot see sugar inside the water. After stirring, we can see sugar disappears. Where sugar has gone? Actually, sugar gets mixed with water, or we say sugar dissolved in water. When you taste this water, it is sweet because sugar mixed with water, sugar dissolved in water. So if we drink that water, we taste it as sweet. It tastes sweet. This is because sugar has dissolved in water. Yes, so when we put sugar in water, what happens? Sugar gets dissolved in water and we get a sweet water, isn't it? Yes. We say sugar dissolved in water. When a solid such as sugar, so sugar is a solid. When a solid such as sugar is dissolved in a liquid such as water, so water is a liquid. It produces a solution. The sweet water is a solution actually. Produce a solution. Yes, solid and liquid produce a solution. You can see the image here. You can see the tiny sugar cubes inside water in the still water. After stirring it, what happens? Sugar cubes get distributed here and there. It dissolves and we get a sugary solution. Yes. The substance that dissolved in a liquid. The substance that dissolved in a liquid. This substance It is said to be soluble in liquid. So sugar is soluble in water, we say. It's soluble. The solid that dissolves in a liquid is called solute. So the solid which dissolved in this water or in this liquid, the solid is called actually solute. S-O-L-U-T, solute. The liquid in which the substance dissolved or solute is dissolved here in the liquid. So the liquid in which the substance or the solute dissolved, that liquid is known as solvent. So this is actually solvent. So the substance, the substance that dissolved in the liquid or the solid that dissolved in the liquid, that solid is solute, and the liquid in which the substance dissolved, the solute dissolved, that is solvent, and the substance we get after mixing solute and solvent is solution. Yes. So the conclusion is solute plus solvent gives a solution. Solute and solvent mix up to give solution. Example, sugar and water. The same example we can see in salt and water. Solute is salt. Salt plus water, we get salt solution. This is another example. Same like sugar, we get salt solution. Salt also dissolve in water. Salt also soluble in water. The substance which is soluble in the liquid, that substance is, that solid is solute, and the liquid in which the solute or the solid dissolves, that liquid is solvent, and the substance we get after mixing solute and solvent is a solution. Example, sugar, water, salt and water is a solution. It's an example of solute, solvent and solution. In a sugar solution, sugar is a solute, water is a solvent. Similarly, in a salt solution, salt is the solute and water is the solvent. And the salts, water we get, sugar, water we get, it is solution. So that is dissolution of solids in liquids. Solid is dissolved in the liquid. Sugar in water, salt in water. Next is dissolution of gases. Gases in liquids. How the gas dissolves in liquids? Let's see. Many gases like oxygen and carbon dioxide dissolve in water. Yes. How you know? In water, plants and animals are there. Plants and animals live in water. How fish breathe in water? Many fishes are there in the water. How they breathe? Because there is oxygen in the water. With the help of that oxygen, they breathe and they live in water. So oxygen is there in water. Is dissolved in water, we say, isn't it? Yes. And what carbon dioxide example, if we say, when we open a soda bottle or any cold drink, if we open, what happens? A sound comes out, isn't it? It's a gas. When we open a soda bottle, the gas comes out suddenly. It escapes and we can see small droplets around the bottle. It is carbon dioxide actually. Yes, so carbon dioxide is also dissolved in water. Carbon dioxide is a gas, isn't it? Yes. Carbon dioxide is dissolved under pressure in soda water or in any other cold drink. See, when we open the bottle of a cold drink or soda, we can see the gas coming out and the droplets around it. That is carbon dioxide gas actually. When we open a bottle of soda water, we see that the dissolved carbon dioxide. Actually, carbon dioxide is inside in the soda, it is dissolved there. It escapes rapidly. It escapes suddenly out to outside in form of bubbles. In form of bubbles, you can see this gases here and there. The water in lakes, rivers, ponds and seas has a lot of oxygen dissolved in it. Yes, water in lakes, rivers and ponds, they all have oxygen in it. That's why plants and animals live in that. Plants and animals that live in water breathe this oxygen which is dissolved in water. So water in all lakes, rivers, ponds, they all have oxygen dissolved in it. Using that oxygen, the fish or plants, animals in water, the living creatures, whatever they are, they breathe and they live. So gas also dissolved in liquid, dissolution of gases in liquid, oxygen in water, carbon dioxide in soda water, carbon dioxide in cold drinks. These are the examples of dissolution of gases in liquids. Yes, so we have seen the example of dissolution of solids in liquids like sugar in water, salt in water. Same like that, we have seen the example of dissolution of gases in liquids like oxygen dissolved in water, then carbon dioxide dissolved in soda water and cold drinks. Isn't it? Yes.